Welcome back to Inclusive Design 24-2020, brought to you in partnership with Barclays Access, Adobe, Intopia, Tetralogical, Improaxia, Intuit, and WebAble. You can follow us on Twitter at ID24Conf, and if you have questions for the presenters, tweet them using the ID24 hashtag for our Q&A at the end of the session. A reminder that ID24 is a respectful community, and you can find our code of conduct on the inclusivedesign24.org event site. Over to you, Alistair.
Thank you, Steve. Next, we have Max Burke presenting about the emergency website toolkits. Over to you, Max. Thank you.
All right, thank you. Hi, everyone. Warm greetings from Vienna. I hope you can hear and see me well, because I had some construction work right outside my window until about an hour ago, but I think they're on a break now, so fingers crossed. Right, so this talk is called the Emergency Website Kit, and it's about a side project that I started a couple of months ago while we were all stuck inside in quarantine. And I'd like to tell you about it today. So for those of you who haven't seen me yet, my name is Max. I'm a front-end developer in Vienna in Austria. That is Austria, not Australia. So there's no kangaroos outside my window, and in my time zone, it's currently 12 a.m. lunchtime. So thank you for joining me anyway. I work at a small software studio called Codista, and I mostly write HTML, CSS, and JavaScript there. And I also like to write about the web on my blog and on Twitter. And speaking on Twitter, a couple of months ago, I came across this tweet by Nicholas Zakes, and he said that he had just received a shelter-in-place alert with a website for more information. But when he clicked the link, the site was down. So what likely happened there is that the site in question was running some sort of CMS, and the people in charge of the site announced the link to thousands of people at once, and all these people flooded the website and crashed the server. And CMS websites like that are very often unable to handle emergency situations because of traffic surges like this. And this is not an isolated case. The Corona crisis has shown that many critical websites, in fact, are not prepared for these situations. So an example for example, from my country, this is from the Austrian State Department of Health. They put up this dashboard showing facts and figures about COVID-19 cases in my country. And unfortunately, it had a data leak where all of that nice widgets and the graphs were powered by JavaScript, and they had some JSON data in the background, and that contained some sensible data. And when they discovered that, they just replaced the entire site with a screenshot of all these graphs, which wasn't accessible at all. It gave no information whatsoever to anyone using a screen reader, for example. And other countries had other problems. The UK government's COVID information site, for example, was built entirely with client-side JavaScript frameworks initially. And they had all these nice graphs and charts as well, rendered in Three.js and React. And again, that made it useless for anyone without JavaScript support, or even with just a failed request. If one of the requests timed out because of a bad connection or whatever, you would just get this, which isn't all that useful. And then even if you had JavaScript support, the site loaded so much JSON data and other stuff in the background that it came down at about 3 megabytes of weight over the wire. And it took an average of 18 seconds to load on a basic 3G connection. That was so bad, in fact, that it prompted developer Matthew Somerville to file an issue with the people in charge about the heavy JavaScript reliance, only to receive the answer that a site like that is not possible without JavaScript. And fortunately, he disagreed with that. And he later recreated the entire site on his own server as an experiment using just basic web technology and progressive enhancement, drastically improving the performance. So it is possible to do this right, but then why does this keep happening? Why are we so bad at this when it comes to critical information? So for most websites, I'd say there are many different concerns. There's stuff like marketing, design, developer experience, whatever that is. And sometimes all these concerns, they are conflicting with each other, right? Nobody really sets out to make an inaccessible website, but they might say, I want to make it load fast, but marketing says that we need 3 different kinds of tracking scripts on the site. And that kind of slows it down. So we have all these people who want different things from a website usually. And that's part of the reason why there are so many bloated, inaccessible websites out there, because something else gets in the way of the main objective, which is to provide value to people. And I think emergency sites are a very special case here, because when it comes down to it, they really have just one singular purpose. As many people as possible need to have access to the critical information they need in that particular emergency. There's really nothing else. Nobody will care about the branding. Nobody will care what stack it runs on. And frankly, it really doesn't matter if it's convenient to the developers. It just needs to work. And this situation is nice in a way because it really simplifies the decision-making process for such sites. Because every single decision in the development can be made by answering the question, does this help more people get access to the information? And once we agree on that, we can define some requirements for emergency websites. So I've come up with these 5 rules, right? 5 traits that a website providing emergency information should have. And above all, they have to be extremely resilient. As we've seen before, we need to expect traffic surges, and we need to expect a lot of people at the same time that need access to the site. And all the other requirements really don't matter if we can't keep the site up under pressure. Then next, if we do get information across, it needs to be highly accessible. We need to ensure that everyone, regardless of their abilities or their technologies, is able to consume and understand the information. Then it's also quite likely that people will access the site on a mobile connection if they're on the go, for example. So it has to be mobile friendly. It has to perform well, even in poor network conditions. We can't rely on a stable broadband connection, and we can't afford to use heavy, fancy JavaScript libraries. Then fourth, emergency sites have to be secure and independent. And by that, I mean that the people in charge of the website should have complete control over its content and its availability on the web. It shouldn't be vulnerable to any outside attacks, and it should not rely on other systems or other platforms for their availability on the web. And finally, it needs to be easy to set up by whoever maintains the site and whoever publishes the information. It needs to be as frictionless as possible to start such a site. Right, so let's talk about the first point here, resilience. A resilient website is one that can withstand everything we throw at it. So it's handling all the unknown variables of the web in a way that ensures that the site is still usable, even under extreme conditions. Now, in this situation, in the question of traffic surges, we might be tempted to solve the problem through scale. With more power, more servers, more caching layers, throw our entire tech stack at it, and try to ensure that way that it never goes down. But that also introduces more complexity. And in almost any system, the more complexity you have, the more potential for error there is. So there might be a smarter way of going about this. There might be a way that instead of adding layers, it might be smarter to take layers away and we can try to achieve resilience through simplicity by relying on very basic error-proof layers of technology that are usually a lot more stable. So by intentionally choosing simple methods, we can make the system as a whole more reliable. And this is commonly known as the rule of least power. The rule of least power is to always choose the least powerful technology suitable for any given task. So you would look at a problem like this and say, what's the least powerful technology we have to provide structured information on the web? And that is just plain HTML. And plain HTML is a good choice here because it's very reliable. There's no potential for script execution errors or misconfigured databases or whatever. It fails very gracefully. So even if the HTML is malformed, the browser will still display something meaningful. And you just can't have the case like with JavaScript where there's some unexpected error and it crashes the whole thing. And it's also very efficient. It's very cheap to provide HTML because when it comes down to it, static HTML will survive almost anything. So without any processing, it's very easy to publish HTML. You just throw it on a server and be done with it. And you don't need a lot of fancy infrastructure. A single Nginx or Apache instance can actually handle a ton of static requests. And it's very resistant to traffic surges because it needs hardly any computing power to do this. And that idea, that's not the first time anyone has thought about this. So back in 2018, when Hurricane Florence first hit the US, I saw something from NPR, which was they started to provide these text-only versions of their sites. A couple of news sites like CNN did this as well. And this is basically just the content, nothing else, no CSS, no images, no JavaScript, because people in that situation when the hurricane hit, they had very unreliable connections. So that was a way of ensuring they still got something. And it's still the same content that they provided on their main site, mind you. It's just stripped of everything non-essential. And I really liked the simplicity of this, and I wanted to build a reusable version of this for other people in emergencies. So I made this starter kit, right? I made a starter kit for emergency websites that enables people to make extremely resilient, minimal, accessible sites. And like most of my site projects these days, I use Eleventy for this. I'm a big fan of Eleventy. If you're unfamiliar with it, it's a static site generator based on Node, developed by Zach Letterman. And so my emergency kit basically takes just a bunch of markdown posts as input, runs them through some transformations, generates pages with it, and outputs a folder full of static HTML. That's how static sites work. And Eleventy is particularly nice in this case because it's extremely bare bones. Unlike, say, Gatsby or others, it doesn't ship anything by default. You don't have to include any libraries you don't want to. You have complete control over the end result. And the whole thing is open source. It's up on GitHub, so anyone can fork this and make it their own. And you're welcome to have a look. I will share the links afterwards. And this is what it looks like, right? It's basically just a very simple blog to publish information. It has exactly two types of pages. This is the home page or the index page, and this is a detail page for each post. It looks really simple, and that's kind of the point. Nevertheless, there are a few helpful things built into this kit to optimize specifically for emergency situations. And let's have a look at some of them. So first, performance obviously is an issue here. And the goal I wanted to achieve with this is to really get down to the smallest performance footprint possible. So we can deliver critical information in a reliable and in a fast way. And ideally, what we want is to have a usable document ready with all the information within the first connection round trip. So the first round trip, that's basically the first interaction between client and server when we request the initial HTML file. And there's this magic number there of 14 kilobytes. And that number comes from TCP itself, from the TC protocol, where the packets sent in the first connection will allow for about 14 kilobytes of data to be transferred, give or take. So this is sort of the earliest possible, smallest window we got for sending any data to the client. And if we can deliver the whole thing in that window, that's a very good footprint. That's a very good baseline to have. So how can we go about doing this? Again, the main ingredient, the main special optimization here is just to remove anything non-essential. But apart from that, we can do some things like inline and purge all of these CSS, for example. We don't need an external style sheet here. We can define a few sensible styles for readability and accessibility and write them directly to the document head. And doing this in 11t is quite nice. We can write our CSS just as we are used to and include it with this partial inside the head and run that through a filter, say CSSmin, for example, to strip away any excess characters and white space. And we get all of that CSS inlined on each page. And then Next11t lets us define transformations, which are basically just functions written in JavaScript here that process each generated page during the build. And we can hook another minification tool in there. I used HTML Nano. So that again strips the white space from all the HTML. But also, since the CSS is included on each page, we can analyze it and see which elements are on there, see which CSS rules apply and which don't, and get rid of all the unused CSS. So this is done with a tool called Purge CSS that just analyzes all of the CSS and removes every line that we don't need on that particular page, reducing the footprint even further. Then small things like reliable old tricks like system fonts, always a good bet. We don't need any web fonts here. It's completely fine to use the system font stack. So that's an older trick by now. It will just fall back to whatever the device in question runs as the system default and use that natively. And then to avoid having any external requests and any external resources, we can do small things like the favicon. So little known fact there is that usually whenever you go to a new domain, most browsers will actually send two requests. They will get the index HTML file at that position, but they also look for a favicon in the root of the site, and they'll do that automatically. So you get another request. And we can avoid that by just inlining the favicon itself into the page as a base 64 data URI. And you can use it like a transparent pixel if you want to get rid of it entirely, or in my case, I just use a nice icon as a default picture. Right, so doing all of that, we get this. This is the entire source code of the homepage. It fits on this slide. So in the first connection round trip, the server returns this bunch of text. And this basically already contains everything we need to render the site. Roughly half of it there, in the top half is CSS. And then the bottom half is content and meta information and stuff. And at this point, we haven't loaded any images that the content might contain yet, but it's probably already useful since most of the information is stored in text. And since all the CSS is already there, it just renders instantly. So on an average 4G connection, we can see content on the screen after about 4 milliseconds. That's so fast, it feels instant. And we're done loading completely after about 166, 170 milliseconds. And for reference, the Google homepage on that same connection takes about 500 milliseconds. So that's quite good. But that is a very nice, stable connection here on my desktop. But then even on a bad mobile connection, like this is running a test using a Moto G4 feature phone and a very slow 3G connection, it still renders the first contentful paint here at about 2.3 seconds. And the repeat visit is visible after about half a second. And that's the very worst case scenario we got for like a cell reception in the middle of nowhere. That's pretty good. It turns out the web is actually pretty fast if you just strip it of all the JavaScript and the images. Right, so that's performances. Now let's look at accessibility. It's important to make the emergency information we got accessible to anyone. So fortunately, again, if we made sure not to mess things up in the first place, there's not that much special work we have to do to get it accessible. Browsers and screen readers are very good in interpreting HTML documents, provided they have the proper structure. So above all, of course, we need some proper semantics. I'm sure you've heard this before, and you will again from other people today. My colleague Manuel is on in about 2 hours, and I'm sure he'll talk about semantics as well. But yeah, we can start with a base layout that has proper landmark regions like the header, main, and footer there. And then on the detail pages where we have the actual posts, we can enhance it even further by using semantic elements and microformats to give further hints to search engines to make it better indexable and make it accessible. And then even for some more non-standard elements, we can use appropriate roles and ARIA attributes. So this, for example, would be a status message. We will see that later in a little bit. Well, think of something like a little toast message that sometimes come up on a website. And we can use an ARIA live region there to have screen readers announce this out of order as it comes up. And the polite attribute, the polite value in the ARIA live attribute there will tell it to finish whatever it is on currently announcing and then say this message. Right, a couple more things. We can use visible focus styles. We can override the browser default with something a little more visible. This uses a 5-pixel outline. And we don't have to differentiate between keyboard users and mouse users there for the focus ring. For some other sites, for design reasons, we sometimes have to use something like focus visible or a polyfill. But again, on this site, it's fine if everyone sees the focus styles. Everyone can benefit from the increased visibility. Then the whole site is done using REM units, using flexible sizing. So that way it can seamlessly scale up with the user's font size preference, and people with a larger default font size will get a larger website, a more readable experience. That's just by using REM units. On the issue of color contrast, the colors are chosen to pass the Web Accessibility Guidelines AA standard. It uses just one primary color, and it makes sure that we don't differentiate interactive elements just by color. So we have the underline for links here as well. And it's tested with different types of visual impairments as well, such as protanopia, which is a red-green visual impairment, and contrast loss. And you can simulate these quite nicely to the Firefox accessibility inspector. Right, so that gives us a pretty good baseline. That gives us the 400s in Lighthouse. That's a very fast, resilient, accessible website. But automated testing only goes so far. That's just first indicator. There's a lot more to consider than a perfect X or Lighthouse score. So for example, we can look at things like removing cognitive barriers. It's very possible that people that are in a somewhat stressful situation when they come to the emergency website. So we should try to make the experience as self-explanatory and frictionless as possible. Nobody who's in an emergency has time to figure out a complicated UI while they're seeking shelter, for example. So that's why the kit does not include any navigation, any classical hamburgers or flyout menus or whatever that you have to figure out. It's just these two levels, and you just go back and forth between them. And beyond that, we can aim for language that's as plain and as actionable as possible to give people really concrete instructions on what to do. and not have them think too much. And then we can use progressive enhancements to improve the site even further, because there's another situation that we have to think of where users lose connection entirely. So fortunately, the COVID crisis doesn't affect our internet that much, but there are other emergencies, for example, with natural disasters, where something like that can damage network infrastructure. And the fastest site in the world won't be of much use if people can't go online anymore. And it's not hard to imagine a scenario like that. Take, for example, the wildfires taking place in Northern California right now. Some areas there had fires damaging the cell phone towers, and it threatened to take out the internet in that area. So it's very possible to have a situation where people might initially have access to the internet, but then infrastructure is destroyed, or they have to seek shelter in like a cellar or bomb shelter in a place with no network connection. Another case there happened in Sri Lanka a month ago. They just had an entire blackout in the entire nation, affecting all of the country. So all wireless networks went down. And this is where a service worker can really help us. So a service worker is basically just this piece of JavaScript that acts as sort of a mini proxy server and installs itself on the user's device. And we can generate such a service worker using, for example, a tool by Google called Workbox. That's what I used. And we can pass this tool these glob patterns here. And after our site is done building in 11t, that Workbox tool will look inside the HTML folder and match all the HTML files in there and register it in the service worker to be provided offline later. So whenever someone visits the site for the first time, they will get the document, and inside the document, the service worker registration. So you see further down here, it loads this sw.js, which is a service worker script. And then that in turn loads all these resources, these index files. And in that case, this is the index page and then the page for each individual post. And you can see it uses this little query at the end, the WB revision, which is a hash of the file that Workbox generates for us. So whenever the file changes, that hash will update and it will automatically be replaced. And that means all these posts are now stored on the user's device. So even when offline, these files are still present and they can be served like usually. So you can see here that even when I switch my network to offline and reload the page, I can still access the site. It's served from service worker there. And anyone who's had access to the site once will be able to access it later, even if they are in a situation without a network connection. So that's cool, but there's also a big drawback to this. Because whenever we cache something, this introduces the problem of stale content, right? Offline users will see the version of the page that was cached on their last visit. And with critical information, that's not good. We want things to be as current as possible. They could have changed in the meantime. So we need to ensure that the user is aware of that. And the first and easiest step we can do there is just to include a timestamp. So down here in the footer, we can see this last update, which is just a timestamp of the last build that 11t has run. And then we have dates on all the individual posts, just to give the user a sense of how current the information they're seeing actually is. But then there's also the event of somebody browsing the site and then losing connection in that instance. And they might not actually see that they've lost connection because they can still use the site. The next click will go to the cache, but they might not know that. So we can alert the user that they're now offline by using the navigator online, property with this offline event down here. And we can use that to trigger this little notification in the ARIA region that I've shown you before. And finally, there's another scenario we have to think of, that has to do with the way that service worker works. Because if somebody has visited our site, they have an installed service worker on their device. And then when they come back later, the service worker doesn't get replaced instantly because they have this thing called the waiting phase, right? Where the new service worker, if it has updated, will just wait for the current one to be deactivated, which is usually when the user navigates away from the site, and then that new service worker takes over. And that again is not ideal because the user might see outdated content and be unaware of it. But we can improve that by calling the skip waiting method inside the service worker. We can also define that as an option inside the workbox script, so it will include that for us. And now, whenever someone visits the site and the service worker gets replaced, they will see this update notification down there, where they are in charge of actually updating the page themselves. So they can click this button, and then that's a way clearer way of showing what has happened, and the user is aware that there might now be new information to look for. Then there's also the issue of security and independence. An emergency isn't always perceived the same by everybody. There could be stuff like political movements, for example, that deal with a lot of pushback. And still, people will need access to information to organize, and it is vital for the organizers that that information is not vulnerable to outside attacks and can't be blocked or edited by whatever platform it is hosted on. And static files, again, are a nice fit there, because unless someone has actual root access to the server, you can't edit static files through an attack like an SQL injection or flaws in the CMS, for example. And they're also completely independent of any tech stack that might be in place, right? A lot of organizations have somewhat dated systems, an existing server that runs, I don't know, PHP or .NET or whatever. And the beauty of this is that it's just a folder of static HTML that can actually be used outside of that system, completely isolated. Because literally any web server can handle it. And even if there are legacy systems in place, you can just treat it as an isolated part of it and throw it on the web server. So that gives you a high level of technical independence, and also independence from publishing platforms. You're not dependent on creating a Facebook group for this or whatever. Right, so that is the technical side of things. But there is yet another completely different problem there. And that is that not everyone is a web developer, right? Not everyone is comfortable using Node or 11t or the command line, or has even heard of these things. In fact, there's a very high chance that people in charge of getting the information out won't really know how to use this emergency website kit. And there might not always be a developer or a dedicated IT team. And this is something that is actually a problem in a lot of open source projects. They have these getting started or README sections that say nothing more than just run npm install and configure this using the command line. And I think enabling people with another technical skill set starts with an inclusive documentation that doesn't assume any prior knowledge. So that's why the documentation on the emergency kit has this option for people to say, hey, I'm not a developer, I don't know what all that stuff is, but I need to get something out there quick. I have relevant information that needs to be out there. And essentially what we want there is a no code setup process where people don't even have to open a code editor or touch the command line to use it. And something that's quite useful there is Netlify. Netlify is a hosting service for static sites. And it has this nice ability to deploy a website straight from a Git repository without ever touching a line of code. It's basically a process that forks the repository, deploys it to Netlify's global CDN, gives it an SSL certificate, sets up the domain, and all that stuff you have to go through in a very smooth process with basically just one click. So you get this button that you can put in the documentation, and that will start the process for you. And what's more is it's even possible for us to define these template environment variables that we want to use in the emergency site. So we can use a special kind of file inside the repository to set things like the site title, the language, contact phone number, and other stuff. And whenever someone does that one-click deployment thing, you will see a screen similar to this, where all these variables get translated to nice inputs where they can just put that in while they are deploying the site. And that basically then translates to regular environment variables like this here that we can use in the build process. So that makes it possible to customize pretty much everything except for the actual posts themselves right in the setup process. And then once the site is deployed to Netlify, we can use their static site CMS. So they have this Netlify CMS. And instead of touching the markdown files and editing them in an editor, you can access this with some credentials, and you get this nice admin interface. If you change something there, we will create a commit to the repository and will trigger a rebuild. But it's a lot more familiar to people who are who maybe not as comfortable with code or markdown. And this is a much better experience for them to create and maintain content. And again, this is basically already set up inside the repository. So all we have to do is generate or set up a user there. And it will give you a preview of what the post will look like when it's published. And we'll even give you something like an editorial workflow where it's possible to have a team of people working on the information that's going out. It's quite likely that if it's critical information, you want to reduce the possibility for factual errors in there. So you want to make sure that whatever goes out is properly reviewed and ready first. And that way, whoever's in charge of the site can organize and publish information efficiently. Finally, I welcome anyone who wants to contribute to the project. And if you're interested, here are the links. This is the GitHub repository. This is a demo site I've made using it. And this one is a blog post I've written about it. And I know that this is by no means a perfect solution. It started out as a side project, but it's grown very fond of me. And I hope it can do some good. I hope this has some real applications, but there's another side to this as well, because to me, this is a very interesting project because it forces yourself to think about websites in a very, very user-focused way. So there is zero room for anything that does not directly improve the outcome for the end user in this project. And I think that's a position that we rarely get to take in our day-to-day work when we work on regular client projects. So it's sort of a good exercise in training yourself to think about these scenarios and putting the user first. And I think it's important to remember that these are good practices for all websites and not just the ones dealing with emergency. Most of this is just focused on good performance, good accessibility, and low complexity in general. And I think everyone can benefit from that. And your website may not be an emergency site, but for some users, your site could still be very important. You never know who depends on your services, and it never hurts to treat your work with the same care and diligence as if it was critical to people. I think it can make all the difference. Thank you.
Thanks, Max. That was an excellent talk, really interesting stuff. And
Thanks.
I think that you know, what you've created there, even though it's just a side project, is a very useful project. I mean, I was just particularly taken by the non-developer method of publishing a website. It's a great idea. But the whole thing, as you said, it's all about user first, simplicity, and it's these sort of lessons that should be taken on by developers for all websites. So really appreciate it. Alistair, do we have any questions?
Yeah, we did. A couple of quite specific ones. I'll start with those. Chris asked if it's possible to check what's in the first TCP packet in DevTools, or do I have to man in the middle my connection?
Not to my knowledge in DevTools that is possible. So I think using some sort of command line interface and a man in the middle attack, if you will, you might be able to inspect that. I haven't personally tried that. I've
Presumably
just tried.
Presumably you could, at least in DevTools, you can check you're under about 14K for that,
exactly
for your main file.
So yeah, it's possible to just sorry, let me bring that up. To go inside there and check which part of it gets loaded first. So nope. Right. So something like this, where you have the network tab, you can see the uncompressed size here. And if you're under 14 kilobytes, you can be pretty sure that it will fit inside the first packet. But yeah, that's probably
great. Another very specific question. When you were talking about having the favicon inlined as base64, Nils asked if it's possible to do that with inline SVG as the favicon.
Yes, it is possible now, since we now finally have SVG favicons, and you can construct the data URI not base64 encoded, but just with plain SVG markup in there. You have to be careful about stuff like quotes, but that is possible, yeah. And it's probably also a smaller way of encoding these things if you don't have to base64 encoding it.
Right. And I had a sort of couple of more general, oh, actually, no, there was one other question which, well, it wasn't a question, but somebody was wondering if you could use something like Gatsby for the same sort of approach, but I would guess that would probably blow your size budget pretty much straight away. Do you think that's the case?
Yeah, so I've deliberately chosen 11T here, as I've said, because it doesn't come with anything by default. You can really control every single byte that goes out there. Whereas Gatsby, being based on React, usually ships a lot more JavaScript. And in this case, I'm not saying that Gatsby couldn't do it, but for me, it was a better fit to use 11T because it's more bare bones. Gatsby has something like the service worker generation. There's plugins for that you can use, I think. But yeah, you would still, I think, end up with a lot more JavaScript, and I don't think it will be possible to meet that 14 kilobyte size budget.
Yeah, and like Steve, I was very taken with the sort of Netlify kind of non-technical interface. Do you know if it's possible to sort of customize that at all? For example, if people are trying to insert images, can you require alt text or put size restrictions on that sort of thing?
You mean in the environment variables set there?
Yeah, or just in general when you were showing the Netlify editing interface.
Yeah.
I was wondering if it's something that you as a developer can edit. I think it was on the next slide, maybe, with the where people are adding content.
Oh yeah, this is an
editable
Netlify CMS. Yeah, you can to some extent you can customize that. I mean, this is since it runs on a static site, this is JavaScript based. But yeah, since it will only affect the people creating the content and not the vast majority of users, I think that's okay. And you can, to some extent, customize, for example, how this editor will look like. So you can say, my template uses a title, a date, and the body field, but you can also say it's possible to, I don't know, add categories there or an image field or whatever you want. So to some extent, yeah, you can customize it.
Great. And then I think the final one was I was wondering, I mean, for some of our clients, they sort of want to keep things within the same environment. I was wondering if you think it'd be possible to almost create something like a Drupal module, or I'm just using Drupal as an example, but you know, like an open source CMS, which had a specific functionality to publish to a separate subdomain and use different templates and essentially publish as static HTML. Presumably, you could sort of get to the same end place with that approach.
Yeah, I suppose if you end up with static HTML, this is kind of the point. So that's why it doesn't use Drupal or any CMS in the first place. But I know that there are plugins that sort of take the input from, let's say, a Drupal CMS as a headless source of content, and then generate static HTML from there. It would be possible, I suppose, to keep the same CMS interface that people might already be used to, but change how it's presented to the front end and how it's generated. So that might be an option for people who don't want to switch to a new environment, which I totally understand.
Great, thanks. Steve, I think back to you.
Yeah, thanks, Alistair. Thank you again, Max. If you like this session, hit that YouTube like button. And don't forget you can subscribe to YouTube/InclusiveDesign24 to be kept in the loop on our future events. A reminder that Inclusive Design 24 is brought to you with the thanks to Barclay Access, Adobe, Intopia, Tetralogical, InfoAxia, Intuit, WebAble, DayQ Systems, and the one and only Adrian Rosselli LLC.